Lights Out is a puzzle game in which you should try to turn off all the switches or lights that are arranged in an n by n grid. The rule is that when you click on a cell, along with each of its immediate neighbors switch from on to off or off to on. We name ones with some lights, raised from the beginning Holey lights. Research has shown that a solution can be obtained by expressing lights out in linear algebra and solving for it. First, we examine what it means that there is no solution. By distinguishing between solvable and unsolvable lights out, we can narrow down the problem to multiple ways in which the problem can be solved from all button presses. From these results, we can find the optimal solution for lights out. As a result, examination of invariants in solvable and insoluble games proved that if the number of on switches placed in specific cells on a 4x4 or 5x5 grid is a determinant. If it is an odd number, the game is insoluble. According to this result, if there is anything that has a pattern which can't solve any lights out, we can judge whether we can solve with the number of on switches placed in specific cells. We designate each switch of lights out as SAB. A is row, B is column, A and B is 1 or more, and 5 or less. We defined the time of changing SAB as BAB and the time of pushing SAB as QAB. Then we can get a system of equations. If we add up some equations from this, we find a remainder of left member does not change. So if a sum total of specific switches lining up is odd number, the lights out can't be solved. There are most sets of specific switches like this. In the similar way as 5x5, we designate each switches of lights out as SAB. A is row, B is column, A and B is 1 or more, and N or less, and the time of changing SAB as PAB, and the time of pushing SAB as QAB. We can get the system of equations when you sum up some equations and write member equals 0. If the sum total of switches lighting up is odd number, the lights out can't be solved. On the other hand, there are some lights out that does not have a pattern which right member equals 0. The lights out can be solved in any case. We designate pushing SAB as NAB. Switches changed via operation as MAB. Operation which include multiple pushing operation can be expressed by adding up each group of the switch. System of equation PQ and the group of NM take the same form. Thus, when the right number equals 0, pushing same switches change no switch. In this time, we converted formulas to figure of actual switches. From now on, we want to think that what mean does the shape of actual switches have and how to find the optimal solution. We also wanted to explore other possibility which is different from the formulas used in this study.